Hello, welcome to Mat-073. My name is Rob Reynolds, and today we're going to be looking at our last sections in Chapter 3. 3.7, we're going to be solving systems of inequalities using the graphing method. So, first of all, we want to determine whether a point is within a solution or not. We're going to simply evaluate this function at the point x, y, and see if this point satisfies. So the first thing we want to do is let x be 5 and let y be 2 and just see if it's greater than or equal to 12. So 15 minus 4 is actually 11, which is a false statement. So the solution here would be false. This point is not going to satisfy this system. So next we're going to look at solving for all of the points that satisfy this system, and we need to talk about some boundary lines. So if they use the bar underneath, then it's a nice solid line. This would be solid, and if they just use greater than or less than signs, then we'll dash it. So I'll show you some examples of solid and dash, and then I always like to check 0, 0. It's a quick way to kind of check to see if I've shaded in the correct direction or not. So remember how to graph in slope-intercept form, y equals mx plus b. I call this the start value, which is the y-intercept. So we start at the y-intercept and put a dot there. The y-intercept is where the line crosses the y-axis. And then I'm going to perform my slope. And the slope is in front of x. And in this case, it's 1/2. So I'm going to do my rise over run. So from the start value, not the origin, from the start value, the y-intercept, I'm going to rise 1 and run 2. And I would recommend you fill up the graph, rise, run, run 2. And that way, you have a nice straight line with several dots. Instead of going up and to the right, we could go down and to the left. And then I'd pull out a credit card or student ID and try to draw a nice straight line. However, that is not the line I need. I can see that there is no bar underneath, so it's not equal to the line. It's either above or below the line. And since this is a less than sign, less than points to the left, and you can write the word less than, and less than means I'm down here, so the y values get less. So here's a positive 10, here's a negative 10, they're getting smaller and smaller this direction. So I would shade everything below this line. And that means everything in this green section, except for the values that fall directly on the line, should be a solution. For example, this point, whatever it is, over, I don't know, 7 down 1, 7, negative 1, should satisfy this system. But again, I always like to check 0, 0, and I see quickly that 0, 0 is not shaded, so I want to make sure that this is a false statement. 0 is less than 1/2 of 0 minus 1. Remember, I want this to be false. 0 is less than 0 minus 1. Is 0 less than negative 1? And that truly is false. So this is the fastest way to kind of check. I feel pretty comfortable with this being, instead of checking all of these points in the green, which there are infinitely many, I usually just check one point, and I check 0, 0, and I feel pretty comfortable. It's a nice dotted line, and I'm shading everything below because this is a less than sign. And so here's how the author goes through and solves it, but they have something very similar. Sometimes equations of lines are given in standard form, and so instead of y equals mx plus b, I would recommend graphing x-intercepts and y-intercepts. So I usually make a quick t-chart here and throw some zeros in. Because to find an x-intercept, you let y be 0. So this one would be my x-intercept. This would be the y-intercept. So to find an x-intercept, if you let y be 0, that kind of drops this term out. And then if I divide by 2, I can quickly pick out a point 3, 0. And that's on the x-axis. Then I'll go back and try to let the x be 0. In other words, I'm going to find the y-intercept, where the line crosses the y-axis, by letting x be 0. And if you let x be 0, that drops this term out, because 2 times 0 is 0. Dividing through by 3, and I get a y-intercept. That's a point that crosses the y-axis. The other thing that I've taught in some earlier videos is that monkeys wouldn't prefer apples over bananas. A quick little saying to find slope in standard form. And so if A is equal to 2 and B is equal to 3 and C is equal to 6, which I don't need that information, then I could do the opposite of the A term over the B term and get slope very quickly. And I can check slope. And when I'm checking slope, I see that I didn't properly graph this. This should have been at 0, 2. So I saved myself by looking at the slope. So this should have been down 2 and run 3, and it is. And I can do that again. Down 2, run 3. Instead of going down and to the right, I could go up and to the left. Again, this takes a little bit of time, but it's worth it because then my line is nice and straight and accurate. Then I check to see if it's a solid or dotted, and this time I can see that it's a solid line. And then I check to see if I'm going to shade above or below. And because this is greater than, then I will be shading above. So again, if that's a greater than sign, actually it says y is great. Now I want to look at this sign, and I'll talk about that in the next lesson. If that's a positive, then I'm good to go. But it does say y is great, so y gets great way up here, and then so I just continue shading up there. So all these values should work, except to check 0, 0. I can see 0, 0 is not in that shaded green area, so let's check it. Let's plug a 0 in here. 0 plus 0 is greater than or equal to 6. Remember, I don't want that to be true. And sure enough, that's a false statement. So again, I'm feeling pretty good by checking 0, 0 that that's not a solution. And again, here's how the author worked it out. So be careful. What happens when I stick a negative in front of this y value? Remember, for inequalities, when you divide through by a negative, you have to flip that inequality sign. So this looks like shade above, but this will actually be shade below. And that's because if you were to spend the time, which I wouldn't recommend, if you were to spend the time to solve for y, you would have to flip that inequality sign. But again, I don't subtract. Some people are real big on getting this into the y equals mx plus b form, slope-intercept form, and I would not spend the time to do this because students forget to divide every term through by negatives. There's a lot of sign changes here, and then they forget to flip this inequality sign. So I could, if you wanted to, put this in this form, but let's show you how to work this problem by using x and y intercepts again. So I would make a t-chart, throw some zeros in. If you let x be 0 and divide through by -2, I'll get a -6. If we let the y value be 0, that'll wipe out this term. Divide through by 3, and I get a 4. I'm going to plot those points. 4, 0 is here. 0, -6 is down here. I look to see if it's solid or dotted, and it looks like it's going to be a dotted line again. And I should have done my slope over and over again so I have nice straight lines. And then I check to see if I should shade above or below. So again, be careful. I already know that I'm shading below, but let's recap this one more time. It looks like this is a greater than sign, so it looks like I should be shading above. But because there's a negative out in front of the y value, don't care about the x, I'm going to flip this inequality sign from greater to less. So less than means I'm down here, and I would shade below. And for the third time, it looks like 0, 0 should not be a solution. So I'm going to check 0, 0 again. And if doing so, I get 0 minus 0 is greater than 12. And remember, I wanted a false statement. So once again, 0, 0 does not work, and it's false. And I'm feeling pretty good, again, about that solution. So here are the book suggestions of step-by-step procedures of how to solve those inequalities. So when you're graphing x equals, remember this is going to be a dotted line because I can't accept the values on the line. But every y value that I choose, the x value will always be 2. So this is a nice vertical line. It has no slope and dotted, but I want all the values that are less than. Remember, less than points to the left. So I'm going to shade off to the left. And notice 0, 0 is a solution this time. And so in checking 0, 0, it should be a true statement. So 0, 0 is being shaded, and let's plug it in. Is 0 less than 2? That is true, and I'm shading that point, and I feel pretty good about that solution. Similarly, we've got y equals negative 3. That means I've got a horizontal line at y equals negative 3, no matter what the x value is. X could be negative 4, x could be 9. No matter what I choose, the y value will always be negative 3. That's a horizontal line with 0 slope. This time it's a nice solid line though, and the reason why it's a solid line is because I can be equal to it. And looking at shading above or below, this says y is great, so I want to shade up here. And in doing so, I will shade 0, 0. So checking 0, 0, I want to make sure that it works. And it does, because 0 is greater than or equal to negative 3. That's a true statement. And again, here's the author's solution. So solving systems of inequality means I'm going to have more than one function. So I'll graph vertical line at solid at x equals negative 2. But this time I'm not going to shade everything to the right. I'm just going to do little alligator teeth to the right. To remember, I want to shade to everything to the right. The solution, I don't know where it is, but it is off to the right of that line. And then I'm going to do x and y intercepts, because this is in that standard form, ax plus by is equal to c. So I'm going to make a t-chart and throw some zeros in. If I let x be 0, divide through by negative 3, I get a negative 2. If I let y be 0, I get a 6. 2 points determine a line, 1, 2, 3, 4, 5, 6. And y equals negative 2. I should probably find my slope is equal to negative a, which is a 1, over the b value. So I know that the slope is 1/3, so I could rise 1 and run 3 and find several more points. I know that this is going to be dotted because there is no line underneath. And I'm going to shade, it looks like I should shade below because this is a less, but because that's negative, I'm actually going to shade above this blue line. So again, I would encourage just little alligator teeth above. And then if I talk about where the alligator can eat, I've got region 1, region 2, region 3, or region 4 to shade in. And it looks like region 1 is the only region that my alligator can eat. because he's got teeth along here, and he's got teeth along here, and he's going to be chomping in this area. All the other regions, either he's missing a set of teeth or both teeth. In region 3, he has no teeth at all. So again, I would check 0, 0 and see if it's a solution. So yes, 0 is greater than or equal to -2. That's true. And 0 is less than 6. So it's true for both scenarios. So I feel pretty good about 0, 0 being a solution. So don't do what the author suggests, which is he doesn't use the alligator teeth. He starts shading everything, and it just gets too messy. I can't really tell where the final solution is, and I might get confused and think that this is a solution. So I would avoid getting messy. One last example, or maybe I think it's the second to the last example. Let's call this line A and line B. Line A is in standard form, so again I'll throw some zeros in. So divide through by 3 and I get a 2. If I let y be 0, I get 6. 6 and positive 2. My slope here is -1 over 3. That's the negative a over the b term. So again, -1 over 3 to find some other points. -1 over 3. I could fill up the graph instead of going down. I could go up 1 and 3 to the left. This is going to be a dotted line. And the y value is positive this time. So I can actually go above with it. But again, I would recommend alligator teeth. Shading above. My second line, I'll have a start value at -1. And then I'll do a slope of 2 over 1. So rising 2 and running 1. Rise 2, run 1. I'll fill up the graph with a dotted line again. And looking at the blue, I need to shade above, that's shade below, because it's less than. So I need to shade down here. So alligator teeth in this direction. And then again, I'll look at where the alligator can eat, and he's got teeth all over here. So I'll shade in this yellow region. Notice 0, 0 should not be a solution. So quickly checking that. 0 plus 0 is greater than 6. That's false, which I want it to be false because I'm not shading that. And 0 is less than 0 minus 1. 0 is less than -1 is a false statement, which I wanted it to be false. So I feel, again, fairly comfortable with the solution set being over here. Alright, so this is my last example. Sometimes you have multiple equations. This means x is standing up at 0. It's a solid line. This means x is standing up at 3. It's a solid line. And so I know x is between. So my function, my answer, is going to be between these two vertical lines. I've got a horizontal line at 0. And I've got a horizontal line at 4. So now I know that the solution is in this box somewhere. But I have a line in here as well. So I choose x's and y's. And I'll throw some zeros in. When I let x be 0 and divide through by 3, I get a nice point. But if I were to let y be 0 and divide, I do not want to plot 4.5 or 9/2. Instead, I would use the one nice point that I have, which is 0, 3. And then I would encourage you to find the slope, which is -a over b. Easy to pick off. The opposite of this divided by this. So from the nice point, I would go down 2 and run 3. Notice that I will get an x-intercept of 4.5 if I do that again. Down 2, run 1, 2, 3. This will be a solid line. They're all solid in this example. And again, I can see that it crosses at 4.5, but that was too hard to plot. Let's see. I've got y is greater, and since it's positive, I'm actually going to shade above that. Remember, I need to stay above the line, but I also need to be within my other constraints. And so it's just this small little feasible region right in here that I'm shading. So I have several boundaries. I hope this video was helpful. If you have questions, email me.